This is Shakir Ahmed. In this video, we will discuss about logistic regression. Logistic regression is used to see the relationship between a dependent categorical variable or a binary or categorical independent variables. So, if when we have only one categorical variable, to see the association between the two categorical variables, one independent and one dependent, can call it unadjusted association between the two variables. So we discuss with the simplest case from using data of stroke, where the stroke status is the independent variable and hypertension status is considered as independent variable, and we see the association between hypertension and average glucose level using logistic regression. So here are some assumptions of logistic regression. The outcome should be binary. If we have multiple outcomes, then we need to convert it. You should make it binary. And independence of observation is just in simple linear regression. Here as well, we should have independent observations. There should be no clustering, or there should be no paired observation, like longitudinal data. And there should be no multicollinearity. The variables independent, if independent variables, they should be dependent. There should be no correlation between them, basically. And of the logic basically log of odds. Basically, log of odds is linearly relative to the independent variables, where we assume that the log of odds. And what is odds? Odds is basically probability of having certain condition divided by probability of not having certain condition, probability of having an event and probability of not having event. Here in our example, probability of having stroke divided by probability of not having stroke. So this ratio is called odds. And then uh, we just take log of odds and we model the log of odds through axis. And for different value of x, we get the log of odds on the average, and the difference in log of odds or the ratio of odds. If we just take exponentiate of the coefficient, we get the ratio of the odds that is called odds ratio. So we compare, we see what is the odds ratio, or to compare the odds into groups, we just take the ratio. If the ratio is greater than 1, it means the higher group means, for example, the higher group will have higher odds than of having the condition than the x. So we'll discuss these things. The sample size should be large enough. It depends on the number of predictors you used and number of prevalence of the outcome. If prevalence is very low, then the sample size should be large enough to accommodate those prevalences. So we start with the stroke and hypertension, and for that we are starting from here. Sorry, states model API is SM, and we also need to import the formula. It is called SMF, states model formula. So in this formula we have SMF logit. So SMF logic means we are using logit model. If we write probit, we can also write probit. We use the probit model. Probit model basically relates the probability to the axis using the uh, community function, community distribution of a standard normal distribution. Here it used the logistic distribution to model log of odds are the odds of having the event to the axis. So you just need to put the independent variable and your data frame, and then just print the model summary. Check. So here is the model summary. We have again the model performance measures. We will discuss this later while taking the logistic regression as a classification problem uh, about how model fit and how we can compare different models in terms of model fit. But for now, just discuss the coefficients and their standard error and how we can set it the result is significant. This is the value of hypertension, the coefficient corresponding to hypertension. So, what does it mean? It means 1 unit change in x means x is a categorical variable here. From no hypertension to hypertension, the odds of having a stroke is will increase by 1.3. So this is the coefficient beta. But mostly we need to take exponentiation of this and then explain that exponentiated value to tell the ratio basically. This is the log of odds of having stroke in individual with hypertension minus log of odds of having stroke in individuals without hypertension. So this difference is basically 1.307. This is difference of log of odds. But we are interested in odds ratio, not log of odds. So we just exponentiate this value and we will get the exponentiated value. So you can just write odds ratio hypertension from np dot exponentiate command. Basically, you are using numpy library and differentiate any variable. Then result parameters, and from parameters you can have a lot of parameters. So for this case, we have only one parameter, that is hypertension and the intercept. So we are exponentiating this value. Then you can print the value odds of hypertension and interpretation as you can write. So this is basically the ratio of odds of having stroke in hypertension divided by odds of having stroke in non-hypertension individual. So it is 3.8. It means the uh, people, the individuals with hypertension have uh, at least 4 times higher risk of having stroke than those who don't have the hypertension. You can just write this into for individuals with hypertension, the odds of having a stroke are approximately 3.85 times the odds for individuals without hypertension, holding other factors constant. But this is a simple logistic relation. We have only one variable, so we don't need to write this. It's already printed. You can just skip from here. Then you can visualize these values as you have already discussed, the proportion of the probability of stroke in hypertension individuals and individuals without hypertension using and we are just using the bar plot and title, X label, Y label, and then X ticks. So you can see hypertension, proportion of strokes by hypertension. This is in individual hypertension, strokes, proportion of stroke, and this is proportion of stroke in individuals without hypertension. So you can just see this thing before going to further analysis. Basically, this is your final analysis, the odds ratio and the p-values. In report, the p-value is as 0.00. It means it's statistically significant. So there is a strong association between hypertension and stroke, but without adjusting for blood movements. Thank you.